I spent any more time. Okay. I started my friends on YouTube, but here we go. I'll go back over. So if anyone was not listening 2 minutes ago, I'll just review what I just said. We are doing inverse functions today. One thing I talk about a lot is inverse operations, especially when I'm helping like Algebra 1 kids. I'm like, well, if we're adding, what's the inverse of that? What's my opposite operation? That is what we're doing here, but in terms of functions. So inverses is what we're doing. Like I just said a second ago, that means we switch our x and our y. And in this case, I have my f of x. I know that's the same thing as y. So I can replace my f of x with y. And now I'm going to physically switch those two variables. Instead of saying y equals, I'm going to say x equals. And instead of saying x plus 2, I'm going to say y plus 2. Now what I do is I get y by itself. So I'm going to get rid of that 2 by doing its inverse, minusing 2 from both sides. And that becomes x minus 2 equals y. That's it. That's your new equation. Now, as your math teacher, it's my job to show you the most mathematic, most best answer for this. F to the negative 1 of x equals x minus 2 is the best answer, but you don't necessarily need to put it in that function notation.
Wait, so we can just keep it with the y?
You can leave it with the y.
Wait, why is it -1?
Because that's the notation for inverse. That's just the rule. That's just what we decided a million years ago when we decided to do this. Okay? Similarly for the next one, I'm going to think about getting rid of that f of x. That's the same thing as y. And now I'm going to flip. I'm going to switch where my x and y are. I get, instead of saying y equals 3x plus 1, I'm going to say x equals 3y plus 1. Notice how I leave the 3 by its, leave the 3 where it was, I leave the x where it was, the 1 where it was. The only thing that physically moved was my x and my y. And then now again, I'm going to do my inverse operations to solve for y. So first thing I, minus 1. And then I need to get that y by itself, so I'm going to divide by 3. Now, don't stress yourself out over this. I think this is totally acceptable to write. X minus 1 over 3. I think that's a great way to write it. Again, let me show you the best math way would be f to the negative 1x equals x minus 1 over 3. You may see a shortcut or you may notice a pattern and want to take that. That's fine. I'm going to argue it doesn't always work like that, so be careful with doing shortcuts. I think the best way is physically just switch your x and y and then solve for y to get it by itself. Yes, Megan?
Is it fine if you have y equals 1/3 x minus 1/3?
Absolutely. You can make it 1/3 x minus 1/3. You can make it x over 3 minus 1/3. Whatever makes you happy. If you want to split it, go right ahead and do that. But one thing I love about this is I'm able to be a little lazy and not split it, and that's a totally okay answer too. Okay, go ahead and turn your paper over. I want to skip letter C for right now because it's a harder one. I'm going to go down and do D and E first. So letter D, same idea. Switch your x and your y. I get x equals, the radical still has to stay on that left-hand side, or that right-hand side, excuse me. How do I get rid of that radical? Square, very good. Square, square. Since I'm just squaring x by itself, I don't have to FOIL anything, I can just leave it as is. And then on the right-hand side, my square and square root go away, so I get x squared equals my y minus 4. Now what? Sorry, what? Oh yeah, add 4 to both sides. And I get x squared plus 4 equals y. Or again, best math way, negative f of negative f to the negative first of x equals x squared plus 4. That wasn't too bad, was it? Okay, last one. This is not an equation, it's a list of points. But what have I done every time up to this point? Switch my x and my y's. How am I going to switch my x and my y here? Say again, Quinn.
Just like flip the numbers.
Good. So if my first point was 1, 2, what will my inverse of that be? 2, 1. Awesome. So again, I have an x and a y. I'm just going to flip those. So I'm going to do that for every single point. So my next point should be what?
4, 3,
Awesome. And then I should have 6, 5, and then 2, 7. Very good. And that is my f to the negative 1 of x. Okay. All right, let's go up and do letter C. Let's go up and do letter C. I skipped this one because it's a little bit more algebra and I wanted to kind of get the new concept of the inverse functions in our brain first, okay? I'm gonna cross out my f of x and I'm gonna make that y. Now I'm gonna rewrite this, and every time I see x, I'm gonna have to put a y. So x is changing for y on the other side, and now I'm gonna have 2y minus 3 over 5y plus 1. 2y minus 3 over 5y plus 1. I just will copy all over myself. I think we're okay, but so I guess it was fuller than I thought. That's embarrassing. Okay, now what we have to do is we want to get y by itself, but I have 2 y's, so I need to combine them in some way before I can get y alone. I want to get rid of this denominator. Does anyone have an idea on what I should do first, Ava? I don't want to multiply by the reciprocal. Multiply by what, Barrett?
My 5y plus 1.
By 5y plus 1, multiply it where, both sides?
5y minus 1.
We don't want to do that's the conjugate.
Okay.
I only want to do that with like radicals and i's. I don't want to do that here. Another thing I could think of is, what if I wrote x over 1? No, someone last class said it too. It's a really common thing to think of. So that's why I like to bring up that we are used to doing conjugates. This is not the time to do it. We've got so many things in our heads that I only want us to use certain tools. So not that one. You also can think of it as x over 1, so we can do a cross multiply as well. Whatever makes you happy, but at the end of the day, like Barrett said, I want to multiply by 5x plus 1 to both sides. Or sorry, 5y plus 1, excuse me. I wrote that and then I said differently. That cancels this denominator out, and I get 2y minus 3 on the right side. And then on the left side, I am going to multiply x by 1 and by 5y. So I'm going to get 5xy plus x. Okay. Everybody good so far? Some of you might have been like, oh, why did we multiply that x by these things? Because now we have an xy term. Isn't that ugly? It is ugly, but sometimes it needs to get a little ugly, a little bit messy before we can kind of clean it up. Okay, now I need us to get everything that has a y on one side of the equation and everything that does not have a y on the other side of the equation. So I'm going to minus my 2y from both sides. Oop, that's not the utensil I wanted to be in. And I'm going to minus x from both sides. So that gets all my y's on my left side, and it gets all my not y's on my right side. So I've got 5xy minus 2y equals negative x minus 3. You feel okay about that so far? Okay. Now, I have y in both of these pieces. What can I do?
Divided by 1.
I don't want to divide by y, I want to use another verb. Factor. I want to factor out a y. If we divide by y, then it starts getting messy. I just want to get rid of it. So we're going to factor it out so we can divide by everything else so y can stay by itself. So when I factor that y out, I get y times 5x minus 2 equals negative x minus 3. And then I can divide by 5x minus 2 on both sides. And this is one where I like that I can be lazy because I cannot simplify. I do not want to simplify. This is the best answer I can do. Y, or I can think of this as inverse function, is negative x minus 3 over 5x minus 2. Now, let's go back and look at the original equation. Did our original equation look something like that? Bless you.
Yeah.
See how there was like an x on top and an x on bottom? It's similar enough to where we came from. So there should be some similarities in where we came from. So like I get this crazy function, but I kind of started with a weird crazy function, right? So that's how I kind of check myself and say, oh, it's fine. It looks similar to where we came from. We were multiplying by 5s and 2s and adding 1s and 3s, like we were able to kind of see those similar numbers over here as well. Okay? That's probably one of the hardest ones like this that we'll see. Okay. We're gonna do a little bit more inverse work, but now we're gonna talk about a new vocab word. Does anyone have any questions before I move to number 2? Okay. I see the phrase 1-to-1. What does that mean?
Remember the like.
Sophie's like, I've seen this word. I couldn't tell you what it means. Quinn, tell me something.
Isn't it like the vertical line test? Like there's only 1 point for like each X.
Good. The vertical line test is exactly what we're about to do. The 1-to-1 essentially means that for every 1x, for every 1x value, there is exactly, all right, 4, I guess, every 1x value, there is exactly 1 y. So when I do my vertical line test, essentially I'm looking at 1x. I'm looking at like x equals 2 or something, and I'm seeing how many y's are on that line. And if there's more than 1, then we have an issue. And if there is exactly 1, then we're fine. So if it passes the vertical line test, that means it is 1-to-1. And then that also means it's a function. Like this is the definition of a function. A function is 1-to-1. And so we can check using vertical line test. So let's roll through pretty quick. Letter A, yay or nay? Yay, it's okay. What about B? Nay. If I go through it there at like x equals 2, there's 2 y's that cross through, so B does not work. What about C? Does C work? Is it 1-to-1? Yep.
Yeah.
It has exactly 1 point. And what about D? Is it 1-to-1? Also yes. It hits once. So the only one that doesn't work is B. A and C and D are all okay. Awesome, you guys are killing it. Okay, next one, it says prove the following pairs are inverses. Prove the following pairs are inverses. I need to give you a little bit of background information. In order for them to be inverses, so if 2 functions are inverses, then their compositions will equal 0. So then the composition, and we're going to look at several compositions, or I guess 2 of them. We're going to look at g of f, and I'm going to look at f of g, and they should equal x. So when you put one function inside of the other function, I should get x out as my answer when I simplify it all the way down. If you do not get x out, then it is not inverse functions of each other. The reason we have to check both of them is we need to make sure it goes both ways. Inverses is a 2-way road. One should be inverse of one, and it should also be the inverse of the other one. So we got to check both directions. Excuse me? If 2 functions are inverses, then the composition of g of f and f of g should equal x. Right, Michael? Oh, not even listening. You with me? Okay. All right, so let's go do some inverses. Let's go do some compositions. So I've got f and g. Let's do g of f first. Which is my outside function? Which is on the outside? G. Very good. So I essentially am going to do x minus 2 over 3. But instead of x, I'm going to put in my f function. I'm going to put 3x plus 2. We okay with that? Yeah, Beatrice.
How did you know which one goes first?
I'm going to do both of them. So I just chose to do g of f first, but you could do f of g first and it doesn't matter.
Okay.
Yep, either one. Great question. Again, since I have to do both, I'm going to do both either way. So I just chose to do this one first. Now I technically have parentheses around it because I wanted to be careful when I plugged it in. Do I need to keep the parentheses there? No. Okay, now if I start doing this, how do I start simplifying? What's the first thing I need to do to simplify? I'm going to combine my 2's. I've got positive 2 and negative 2, so those cancel to be 0. Okay, so now I've got 3x essentially plus 0, but I don't need to write that. That's redundant, over 3. What can I do next? I can cancel my 3's out, so that just equals x. That's what I want. Check, we're doing it. We worked the first one. That's awesome. Now we have to do the second one. So now I've got to do f of g. This time, which one's my outside function? Which one?
F.
F, very good.
For the other one, did G.
Say that one more time.
The previous one, you did F of G and then did G of F.
Absolutely. We got to do both of them. It doesn't matter which order you do it in. I don't know why. I just chose g of f this morning to go first. So I'm going to do 3 times x plus 2. But instead of writing x, I'm going to write my g function, which is that x minus 2 over 3. Now, do I need to keep my parentheses here? Yes, I do, because why?
Did you multiply them by three?
Good, so what's my first step?
Multiply.
Multiply by 3, what is that? When I multiply by 3, what does that do? We could do that. I want to go even easier. Quinn, what do you
Drop
see?
3, put 3 over 1 and then cancel out.
So I've got a 3 that I'm multiplying by, and I'm dividing by that 3. So I'm going to cancel those 3's out, and I can go directly to x minus 2 plus 2. Should I keep that x minus 2 in parentheses, or are those parentheses done? We don't need them. They're done. Now what? Good. We combine the like terms. We just get x. Is that what we wanted? Yes. So for both of them, I got x when I did my composition. So I would say yes, they are inverses, or that by itself proves that they are inverses. Okay. Why don't I be quiet? Why don't you try letter B by yourself? Do f of g and g of f. Make sure that you get x out. Now wait a minute, and then I'll put my work on the board. I'll do f of g first this time. Bless you. All right, I did my f of g. I plugged g into f, and I solved, and I got x. And now I'm trying to do my g of f, see if I can get a nice pretty answer as well. We're off to a good start. And I did. So this one, by doing my compositions, I also was able to prove that they were inverses of each other. Again, I was doing, to prove that they were inverses, I was doing the composition. So I might write that up in my notes in case I go back to look and I'm like, what the heck was I doing over here? I was doing compositions. Anybody have any questions on those? Okay, when you're good, then I actually want you to skip number 4 and 5, and I want you to go to number 6. It's just a real quick problem, but I want to keep the inverses all together because, again, I believe this is something that we know. I'm keeping deep in our head what the factored inverse is, and then I'll teach you the other concept in a moment. Good, so go ahead, flip our notes, blah, blah, blah. Okay, number 6 says sketch the inverse of. Okay, when we were just doing this, I'm sorry, Barrett.
So at the end, we've always gotten X. Can you do something other than X?
If you get something like, that's a great question, going back to the last question, if you got something like, if these twos didn't cancel, let's say this was a 7 and we like couldn't move anymore and we just had 2x over 7, is that equal to x? No, so the minute you got that, I'd say they are not inverses.
What if they both are like 2X?
Then they both still, that's not equal to x. You'll see when you do a couple more of these, I think there's some on your homework, but I could be wrong. If not on our study guide, we'll see more problems like this. And it'll be very obvious when they are not inverses of each other. Great question. All right, so as I go to number 6, and I'm gonna sketch the inverses, can you remind me, what did we do algebraically when we were finding the inverse function? What did we just do a minute ago algebraically? We switched what?
Y and X.
The y and the x. So we're still gonna switch the y and the x, which is what Quinn, you were trying to say, is we're flipping our points. I'm gonna show you what line we're gonna flip them over in a second, but in order to flip them, let's talk about how we flip them. We switch all my x's and y's. Now, you don't have to necessarily show any work for this. I am gonna write all my points out just so I don't lose any in my head. Bless you. What you could do is look at a point and be like, oh, well, it was this, and then you can go graph the new point immediately. I just am afraid of messing up, so I'm not gonna do that. So I'm gonna make a list of my original points, x, y, and then I'm gonna switch them. And then once I've looked at all my points, I'll graph all my new points on here, okay? So the first point I see is -2, 0. So that means in my inverse function, I'm gonna have the point 0, -2. The next point I see is -1, +1. So in my new graph, I'm gonna have the point +1, -1. Everybody doing okay so far? If you think this list is stupid, you don't have to do it. You can just graph your new point immediately. I just get worried I'm gonna mess up a point or miss them. So just be careful if you do it that way. My next point is 0, 0, which is staying the same for the next graph, 0, 0. The following point is +1, -1, which then flips to -1, +1. Then I get +2, -1, which switches to -1, +2. And then last is 1, 2, 3, 0, which will flip to be 0, 3. Okay. Now that I've done that, I'm gonna go graph all of these new points. All of these points over here are now my inverse points. So let's see, 0, -2 goes here. 1, -1. Oh, I already had a point there. That's cool. 0, 0. I knew I already had that point. -1, +1. Oh, another point I share. -1, +2 is somewhere up here. And then last 0, 3 means I go up 1, 2, 3, which is about here. Once you do that, connect your new points. Now it kind of looks like some weird astrology figure or like a spider or something. I don't quite know. I like that Quinn kind of mentioned that we are flipping. The line that we're flipping over is not one of your axes. You're not flipping over the y-axis. We're not flipping over the x-axis. We're actually flipping over the identity function, my line y equals x. So I'm flipping over the line y equals x. That's what happens when we switch all of our x and y's. We're flipping over the line y equals x. So that's how my inverse function looks. Okay. We're gonna do the exact same thing on the next one. Do you think you can do it without me? Okay, good. Find your new points, graph your new function. Hi. Good. Can you come?
We'll try.
Hey, good luck tonight. 0, 0, 2, 2, that stays the same, that's cool. And then 3, 0 again. So I got 0, -2, got 1, -1, 0, 0, 2, 2, and then 0, 3 is probably up here. So this is kind of funky because it's not necessarily drawn to scale, but this is another one where it's reflected across my y equals x graph. Thank you, Liam. I'll see you later today. Yep. That's kind of all I got on this part. Is everybody doing okay? Okay. I would argue most of this was pretty review or pretty simple once we did our little graphing. We're going to jump back to number 4 and 5, which we skipped, and we're going to talk about something called parametric equations. Parametric equations. I believe you have never seen this before. Am I correct in that? They are not hard. They are not super relevant. We do not do them a ton, but I do like to make sure that everybody sees them. So I'm going to write it at the top of number 4. I'm on whatever page this is. I'm just going to write a little bit about parametric equations so I can reference back to it later. So parametric equations. Okay. Basically, it means that we have 2 equations in terms of t. One of my equations is going to say x equal blah, 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 something with a t in it. And my other equation is going to say y equals blah, 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 something with a t in it as well. Basically, I took a normal xy function and I split it apart. And t is what we call our parameter. Go write that over here and then I'll zoom out. T equals our parameter. So like I'll tell you what to like plug in and solve for based on what t is. We will graph them in the calculator in a minute, which will be really interesting. But as of right now, algebraically, they look scary. I promise they're not, okay? The first thing it asks us to do, it gives us our 2 equations. The first one says x equals t plus 1. And my other one says y equals t squared plus 2t. Letter A says find the points determined by -3 or t equals -3, -2, ... 2, 3. That means I want to find all of the x values and all of the y values when t is -3 and -2 and -1 and blah, blah, blah until I get up to 3. So we're going to make a little t table. Normally we're used to making our t tables vertically. Just for space, I'm going to make mine horizontally, but you can make yours how you want. Instead of having 2 columns in my t table, I'm going to have 3. I'm going to have a column for t, I'm going to have a column for x, and I'm going to have a column for y. T is what I'm plugging in. So I'm plugging in -3, -2, -1, 0, 1, 2, 3. What I'm going to do with these points is I'm going to find how to graph this function using these example points. Okay, so now we're going to look at the yellow one first. We're going to look at our yellow, our x equals function. We're going to plug -3, -2, blah, 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 all the way in until we finish our chart. So -3, I'm going to do, t is -3. So -3 plus 1 is going to be -2. Then I plug -2 in. -2 plus 1 is -1. You guys cool so far? Can I do the rest in my head? Okay. Good, so I plugged every t value in to my x equation until I got their x value. Okay. I'm going to do the same thing now with my y. But notice that I have to do it twice. I've got to do the number squared plus 2 times that number. I messed this up yesterday. My alpha kids had to help me. So make sure you're careful and don't mess up like I did. So let's see. Okay, I'm going to do -3 squared plus 2 times -3. So -3 squared is 9. 2 times -3 is 6, so 9 minus 6 is 3. Okay. And I'll do -2. -2 squared is 4, and then 2 times -2 is -4. That's 0. Do 1. 1 squared is 1. 2 times -1 is -2, so that's going to be -1. 0. 0 squared is 0. 2 times 0 is still 0, so that point 0. 1 plus 2 times -2 is 3. Plus 4 is 8. And then 9 plus 6 is 15. You don't have to do all that work like I just did, but I messed up yesterday and I was embarrassed. So I didn't want to mess up again today. Just gonna be honest with you guys. Okay, now I've got my little tea table, and I think in a minute we're gonna use it. But before we do that, it says find the direct algebraic relationship between x and y by eliminating the parameter. The phrase eliminate the parameter just means that I want to combine these two equations to be one equation with y equals something with an x. I want to get rid of t. Get rid of t. If I have x equals t plus 1 and y equals t squared plus 2t, the best way to get rid of t is to solve one equation for t and then substitute into the other one. Which one is probably the easiest one to solve to get t by itself? X, like very obviously the easier one, right? You don't have to always do x. I choose to do whatever is easiest. You can do y, but your final equation always needs to say y equals blah, blah, blah. So I'm going to minus my 1 from both sides. X minus 1 equals t. I can do y equals, and instead of having t, we now get to substitute in our x minus 1, excuse me. Now I do want to simplify this, so let's FOIL that x minus 1 squared, and let's distribute that 2 to everything. So I'll FOIL off to the side. X minus 1 times x minus 1 gives me x squared minus x plus 1 is x squared minus 2x plus 1. Are we okay with that, or did I go too quick? Okay. So y equals x squared minus 2x plus 1. And then I'm going to distribute this 2, multiply. I get plus 2x minus 2. Now I'm ready to combine like terms, simplify. Y equals, is there anything to combine with my x squared? Nope, okay, he's good. What about my x's? Ooh, the -2 and the +2 cancel each other out. And then what about my constants? 1 and -2 becomes -1. This equation is the same thing as what we were given to start. But this is in like a notation that we're used to seeing, right? So we're used to seeing normal equations. That is just a parametric equation, which is the same thing as what we see right here. So my direct algebraic relationship is this guy. I'm done now that I did that equation. Okay. Now we're going to sketch this by hand. I want to sketch the points from my graph. So all I care about is the x and the y points up here. We're going to draw a little coordinate plane, and we're going to sketch that by hand. I'm sorry, I can't show both at the same time. Hopefully you can see both of yours. Okay, but I'm going to graph the points. -2, 3, -1, 0, 0, -1. Are you guys okay with that so far? I'm just graphing the points from above. I do not care about the t. The t was helpful to me, but I can only graph the x and the y. So I'm going to graph all of those little points on my graph below. I've got it on the side on my paper. So I'm going to do -2, +3. We go -1, 0. We go 0, You go 0, -1. You go 1, 0, 2 up to 3, 3 up to 8. That's good enough. I'm not doing 4 to 15. I just am not. So it looks like this. My sketch isn't great, but what kind of function does that look like? A parabola. It kind of looks like a parabola. And what kind of equation did I just get when I did it algebraically? And is that the same thing as a parabola? Amazing. And do I have the -1? Do I have the down 1 that I did? Oh my God, I do. How cool is that? Okay. Let's learn how to do this on the graphing calculator, and we can be done after that today. We'll do the last problem next class, okay? So go ahead and get your calculators out. It says sketch the original equations on your calculator. So that means we're going to sketch x equals t plus 1 and y equals t squared plus 2t. Let's see if my calculator wants to work today. It just kind of plays games with me sometimes. Okay, now we're good. All right, so you get your graphing calculator out, and you're like, how fun is this going to be? And then you go to your y equals, and there's nowhere to type x equals, is there? Oh, shoot. This is going to be a lot harder than we thought, right? Fear not. We have to just put this in parametric form. We want to put it in a parametric mode. So I'm going to go press the mode button on my calculator. It's next to second. So click the button that says mode. And we're going to change modes a lot more later this year, but we haven't really done it yet. If you scroll down, mine is number 2, 3, 4. It's the fourth line that says function, parametric, polar, SEQ. Does yours, do you see that line on your paper?
Yeah.
Great. Well, what kind of equations are we doing right now? Parametric. So we're going to scroll over to parametric and we're going to press enter. Make sure that's the highlighted one now. And then if you go press y equals, you should magically see an x equals and a y equals. Whoa, does everybody see it? Oh my God, how cool. I have colors. I don't know if you guys have colors, but in the blue box, so like the x and the y right on top of each other, I'm going to graph those equations. Now my next question is, okay, this is all fun and games with life, but where's the t? How do I find t to plug in here? If you press the normal x button, it now turns into t, because x is the variable we use for functions, t is the variable we use for parametric. The next option we could have done was polar, and that's that omega right there, or theta, sorry, that's a theta. And then the n is for sequence. So as soon as I press the x button, it becomes a t. So I'll press t plus 1, and then my y is going to be t squared plus 2t. Okay, let's just hit graph. I know we're going to have to play around with our window, but let's hit graph. Okay, ooh, very interesting. Okay, you just see kind of like half of a parabola. Okay, go to your window. Can you remind me, what was the smallest t number we plugged in? In my like t table and number A, what was the smallest t value I plugged in? Brian? -3. Do you see how my t min says 0? That means it's only doing half of my graph. It's only doing when I plug 0 in, and when I plug 1, and when I plug 2, and when I plug 3. So if I change that 0 to -3, and I plug my t max to +3, then I should see my graph as I see it. My x and my x min, x max, y min, y max is still like the focus of my graph, so I'm not going to change that. I think I can still see everything, but I'm going to go hit graph now. And do you see how this looks like the half graph that we did before? How can I make it look like the full parabola? What do you think I could go change on my window to make it be the full parabola? -10 where? T min. Let's make our T min even bigger. So we can make our T min even bigger, maybe -10, and I can make my T max +10. And I should now be able to see what looks like a full parabola on my paper. Whoa, isn't that crazy? Thanks for humoring with me by nodding your head. Okay, so we are gonna do another example like that on Monday, but I wanted to kind of like have a little break so we can review this then, because I want to make sure that this is good in your head. We're gonna go on to 1.6. That being said, do your 1.5 homework for Monday. My other class will have to do 2 assignments in one day or have something like that, but you guys can have this done by Monday, so you don't have less homework due later on. Cool? All right, that's all we got for today. Good job, guys. Let me turn this guy off. Oh, he was off center. Sorry, guys.